Okay, so let's continue with more graphs of logarithmic functions, explore a few other options. We want to analyze and compare to the original graph of y equal to log of x base 2, and we're going to come up with a few examples. But the first one is log of x base half. That's the function we're going to talk about. But I want to quickly refresh your memory. If you had a function y equals to 2 to the x, what was that graph in comparison to y equals to 1/2 to the x? Do you remember what that happened? Okay, so here it is. In case you don't remember it, there was that negative because it's 1/2. So here it is, and there's a negative in front of the x. And if you remember what would happen to the graph, let's go to the Desmos. Here we have the two Desmos, the graph right in here. So let's look at it. So the original graph, 2 to the x, is the purple graph that you can see. And then when we have 1/2 x, which was basically 2 to the negative x, is the reflection of the graph over the y-axis. Okay, so that's what happened, and that's what we know that's going to happen. All right, so I need you to pay attention to that and remember that as we are going and maneuvering the logarithmic function. We're going to do the same thing, but I want to show you algebraically how are they related to each other. So we're going to rewrite this 1/2 in a form base 2 in comparison to base 2. I want to show you how they are related. So let's go through and manipulate. So we're going to use the change of the base rule, and that is that. And based on that, I can say that this is log of x divided by negative log of, actually let me do one more step. So this is log of 2 to the negative 1, which is equal to log of x divided by, I'm going to bring the negative 1 to the front now. Here it is. That's the power rule of the log. I'm using that, log of 2. So basically now what we have is negative log of x base 2. So I just went back and changed it again to base 2, and I can do that. So basically this y equal to log of x base half equals to negative log of x base 2. They're the same. And now look at the difference between the two. Okay, so here the log function is the inverse of the y to the 2x, and when we did the half, the base became a fraction between 0 and 1. It was a reflection over the y-axis, but for the log, because it's the inverse, this would be the reflection over the x-axis. So let's go ahead and let's look at that using Desmos. So here is the first log of x base 2. Okay, and now let's look at, so I have a log of x base half or 0.5, and sure enough it's the reflection over the x-axis. Okay, so when you have a base that is between 0 and 1, is a fraction, that's a reflection over the x-axis. So here is the summary when we go from y equals to log of x base 2 to negative log of x base 2. That negative makes the graph reflect over the x-axis. Great. So here's the graph. I pasted on here just to make sure for your notes. And then the other piece of information is that notice that domain and range of the graph stays the same as the original. So it doesn't matter. The reflection doesn't really do anything in this case. So that's basically it. So let's look at this transformation. Let's suppose you are going from log of x f of x equal to log of x to that transformation. And we know everything about this now, okay? So we can actually go ahead and we say the 2, what is that? That's the vertical expansion by a factor of 2. We know that this negative, that is the reflection over the y-axis. We know that this plus 1 is the shift to the left. And we know that this minus 2, let's put it like that, this minus 2 is down, the graph goes down by 2 units. Excellent. Now let's use Desmos and then go through that and let's see what happens. Here is the graph. Now I do have to say that I want to walk you through how you punch in the original function. So y equals to, and then you're going to come up here to the function, you click on that, and then you're going to use the miscellaneous function, and there are tons of different functions, and you want to use, I'm using the log base 10, so I'm going to use that one, but if I want to choose any other base, I'm going to click that one and then putting the value for a. But in here I'm just going to do log of that and then punch in x, and here it is. That's the graph that I get. Okay, so simple as that. And notice that based on this graph, what do we have? We have everything is being shifted, is being stretched vertically. Now the logarithmic graph is an interesting graph. It doesn't give you a lot of specific characteristics like a typical polynomial functions, but you see what is happening. The graph has been shifted, has been dropped down by 2 units. And also notice that your asymptote has been shifted. Your asymptote now is x equals to -1, which is this vertical line right here. All right, that's what that is. Everything has been shifted. So and then the reflection, because originally this graph should have been in here, but now it's reflection over the y-axis, and that's what you were getting right there. So here's the graph. We just want to add one more thing, which is the equation of the asymptote, and you can see that the blue graph is the graph that we have transformed, the green graph is the log of x. Okay, so that's basically it. The domain and range. So notice that the domain in this case will change, right? The domain will end up being all x values that are less than -1 and belongs to all real numbers. Okay, the range, it just doesn't matter. The range continues, and that would be basically y belongs to all real number. Excellent.